So we will look at this question, longest common prefix, and the question is write a function to find the longest common prefix string amongst an array of strings. If there is no common prefix, return an empty string. And here we have the input, which is flower, flow, and flight. And prefix, what prefix means is pretty much the characters that appear in the beginning of a string. So here we have F and L that appears in the beginning of flower, which is also common in flow and which is also common in flight. But let's just say that, so that's why we return FL. But let's just say that we were using the string flower and flow and we did not have the word flight, then we would have returned flow because flow is a common prefix. It appears in the beginning of both the word flower and the flow. So in that case, we would have returned flow. And then we have another example right here where we have dog, race car, and car. And we would return an empty string because there's no common prefix in any of the strings. We have D in the beginning of the first word, but D doesn't appear in the beginning of the second word. So that's why we return an empty string. So the approach that we will take is we will use the first word and we will extract the character from the first word and compare that one at a time with the characters from the second, third, and the rest of the strings. So we will use the first word. So first we will have output equals an empty string, and then we will have first word, which would be strings and zero, and this would give us the element at the 0th index, and in this case it would be flower. So from here we will see like, okay, does F appear in the second and the third string? And if it does, then that's great. Then we will go ahead and we will concatenate that with the output string, which is this right here. And then we will go ahead and we will use the character L from the first word, and we will look for that in the second and the third word or the string. And L does appear in the second and the third string, so that's great. We will go ahead and we will add that to the string. And then we will look for the word O, the character O. And character O appears, we have the character O from the target, from the first word, which is the target char, and we have that in the second string, but we don't have that in the third string, so we will just return FL. So we will do for I in range length, and we will get the length of the first word because we only want to go up to the length of the first word. So if the length of the first word is 5 elements, we just want to go up to the length of the first word, because we are looking for the common prefix. And anything beyond that, it doesn't matter. So if we had, for example, if we had flower, flowers, and flowering, it doesn't matter what the rest of the strings are, since we are looking for the common prefix. So we will using that as a length would work for us. And then here we will do target char, and for target char we will do first word and I. And what this would do is this would give us the target char that we will use to compare to see if the character and the rest of the strings are the same with the target char or not. And then this is where we will create our function, and this function will tell us if the prefix is valid or not. Is prefix valid? And we will pass in strings and target char, and then we will pass in I, which is the index. And if that returns false, then we just want to go ahead and return the output. Otherwise, if that's true that the prefix is valid, then what we want to do is we want to go ahead and we want to concatenate the target char with the output string. And outside the for loop, we will return the output again. And In this case, you can imagine that again, if you were working with a string like flower, flowers, and flowering, since we are taking the length of the first word, we would run out of the for loop. We would leave the for loop, and then we would just be able to return the word flower. Okay, so now we will go ahead and we will create the method isPrefixValid. So is prefix valid, we will have self and strings, and this will be of type list and string. And then we will have target char, and then we have I, which is of type int, and target char, which is of type string. And since we are returning true and false, we will do bool. And for j in range, length, and strings. And we will start this at we will start this from the first element instead of the 0th element, because we are using the first word and we're extracting the target char from here. So when we are comparing this, it would make more sense for us to compare f from this word with f from the second word and the third word. But if we do 0, what that would do, or if we don't have anything, what that would do is our target char would be f from this word, and when we enter this method right here, again we would also be comparing the same character with the same word at the same element. Hope that makes sense. So that's why we will do 1, so we can compare the first word's character with the one that's with the next element, so flow and flight. And here we will do word, which would be strings, and j. So in this case, this for loop, it would run two times, since we start this at once. So the first time when it runs, it would have flow, and when it runs the second time, we will have the word flight. And the first thing that we want to do is we want to make sure that the index is within bound. So we will do if I is greater than or equal to the length of word, then we will return false. Or if the target char is not the same as the character that we are looking at, then we also want to go ahead and we want to return false. So you can imagine that if we had the word flower and flow, and these are the only two words that we were looking at, and we found the words characters flow, which appear in both of them, but when we get to the character E, which would be at index 4, we don't have an index 4 in the second word. And if we don't write this portion right here to check for out of bound, that would cause an out of bound error. So that's why we check for out of bound or out of range right here. And this right here, if target char is not equal to the word at that index, what that's doing is it's looking for each character at that. So for example, when we have target char of f, we will go and see like, okay, does f target char is the same or not as the char right here from the second word and the third word. And if it is, then we can go ahead and we can return true. And so we will do that for the first character, and then we will do that for the second character. We will check, okay, L appears, target char appears in the second and the third word, and that's great, and we can go ahead and we can append that. But when we come to O, we have O in flower and we have O in flow, but we don't have O in the word flight. So that's what this would do, that the target char O is not equal to word I, which would be this right here. So O and I are not equal to each other. So that's why we would return false. And we would just return FL. Since this function returned false, we will just output the string that we have created so far. And we will run this. And we have for I in range length first word. Okay, this should be first. And let's run this. And that looks great. And that also looks great. So now we will talk about the time and the space complexity. For time complexity, we are looking at on, where n would be the number of elements or characters that we have in all of the strings. So here we can add the number of characters that we have here in flower, flow, and flight. So that would be on. That's I guess that is one way we can look at the time complexity. And for space complexity, I guess we can look at it and think about it in terms of OM, I guess, where M would be the number of characters that we have in the first string. So you can imagine that in this case, how we had flower, flowers, and flowering, we would be storing all of the elements that appeared in the first string. But if we have a case like, so that would be the worst case scenario where we would have to store as many elements as there are in the first string.